There we go. We are live. Okay. So, real quick review. Today, test is coming up. We just said it's going to be on Friday. What day?
Let me see what day that would be.
29th.
Around
Because it's prior to October 1st, so we should be good. So, we're going to do some test prep. We're going to change that a little bit, but here's what's on your test. Are you ready?
Ready as I'll ever be.
All right, here we go. Your Chapter 2 test is going to be one day. It's going to be in AP format. What AP format means is half your test is going to be multiple choice, half your test is going to be free response. Now, not necessarily half as far as volume, but half as far as points. Okay? So that means there's 9 multiple choice. They're worth 2 points apiece. Later on, they'll be worth 3. There are 3 free response at 6 points apiece. So each one is 18, total of 36 points. I give you a percentage out of 100 in the grade book. Okay? Now, the typical AP would have the same type of breakdown, and we'll do this on Chapter 3, 4, 5, 6, and 7. But you will have a second set of 9 multiple choice and 3 free response. Do you know what the difference between those two sets are? This one will be with a calculator. This one will be without a calculator, because AP does half and half.
So it's
Okay.
more with the calculator. Wait, no, never mind.
It'll be 9 multiple choice, 3 free response with a calculator, that's with. W with the slash is with. And then you'll have the same exact test on the next day without a calculator. Okay. So that'll be test Chapter 3, 4, 5, 6, and 7. Test 2, we don't do that. Test 2, we just have the one section. So your question is it with a calculator or is it without a calculator?
Is it with a calculator or without?
Thank you for asking that question. I was waiting. It's actually with a calculator.
Oh, thank you.
You're welcome. All right. That allows me to ask any question I want. Without a calculator, I'm kind of limited because you don't want to make them so where you're doing so much computation, I don't get to see if you know the calculus. So I have to be very careful when I write those tests. The ones that are with a calculator, I don't care because you have a calculator. I can put in the most messed up function and you're stuck to solving it. Okay. So here's what's on it. The multiple choice section has limits to a constant and limits to infinity, just exactly like the quiz. Okay? Find the vertical asymptote. Describe behavior to the left or the right. So on yours, you can graph them and just tell me what's happening on the left hand, what's happening on the right hand. Whichever one I'm asking for. Find a point of discontinuity and identify which type of discontinuity it is. What are the types of discontinuity?
0 over 0.
No, that's indeterminate. The type of like for instance, this is one specific type of discontinuity.
Oh,
We call that
that's a jump, right?
it's a jump, outstanding. So it's a jump discontinuity. What other types of discontinuity do we have? Are you recording me?
Yeah.
That's kind of creepy. Just gonna tell you.
Sorry, I want to make sure I
I
get
wish you would have let me know and I would have shown my better side.
Oh, yeah, sorry.
I didn't say that. You can erase that part.
I'll figure out a way.
What other types of discontinuity? Make sure you get Sam not listening.
Having a good day, Sam? Uh-huh.
What other types of discontinuity are there besides a jump? You better know. One of them starts with an R.
Is that the one where we can fill it in?
Yes. Therefore, since we can fill it in, it is a, which is an R.
Recontinuity?
No. No.
Rediscontinuity?
No.
Sam, what is it?
I can take it away. I can take out the discontinuity and put something in, plug it in. So it's a remove.
Oh, remove.
Removable.
Yeah.
Because remember we talked about an irremovable?
Oh, yeah.
So a removable discontinuity. Boy, you guys need to refresh that. And then there's one other type, and that is
That's the one that's just, yeah, and it's just the horizontal asymptote.
it's a horizontal asymptote. So it's a what type of discontinuity?
Undefined, no.
Infinite. Because it goes off to infinity. Even if they're both going to positive, both going to negative, it's still infinite. Okay, so better know how to find the points of discontinuity, identify which type. Find a limit from a graph, like that over there. I'm asking you to find the limit as x approaches 4. or the limit as x approaches 0, something like that. Find the equation of a line given 2 points. Slope. Basic secant line, use your slope, y2 minus y1 over x2 minus x1, and solve. That's actually an Algebra 1 question. Don't miss it. Alrighty? For response, question number 1, I'm going to ask you to do the whole thing. Find the slope of a curve at a point, find the tangent line, find the normal line. I don't ask you to graph them, but I ask you to do all those other things. Remember, 95% of it is finding the slope, 98% is finding the slope, and then the equations you're plugging in. Next is a piecewise function. I'll actually go over this one with an example today. Find k, or any constant, that makes it continuous. Okay, good example of that today. And then it's using the concepts from limits. And then find the exact same question. Find the average rate. That's finding the slope at 2 points. Finding the average rate is right here. Okay, and then you'll find the slope of the tangent line. To find normal, then find the normal line. So.
Awesome.
All right, so that's the test. Now, a couple examples, like for instance here. What value of A would make this equation true?
Would make this equation what?
I'm sorry. Not true. Would make this function continuous. What value of A would make this function continuous? Okay, so if we look at 5x plus 2, and we simply find the limit from the negative side. Okay? What's the limit as x approaches 1? Because linear is going to be continuous, right? 3x minus a is a linear function, so it's going to be continuous. So they simply have to match up. If we have a linear and a linear, in order for them to be continuous, I simply have to make sure, I'm going to go here, make sure that this, I drew. We have to slide it up. Slide it up so that it's on top, so it's next to each other, so it connects. Okay? So that's all we have to do with linear.
So we kind of just create an absolute value in a way?
No, not necessarily absolute value. That was just my drawing. Because it could be like this and then like this. It could be like this and then something like that. Those are not absolute value, but anyway, you get the idea. They have to connect. So let's take the limit. Let's take the limit from the negative side. So the limit as x approaches 1 from the negative is what? So how do you find the limit? You simply
Just plug it in.
plug in. What do you get?
7.
Did you say 6?
I said 6.
Okay, it's 7. Because
Yeah.
5 times 1 is 5 plus 2 is 7.
Yeah, and then I
All right?
corrected.
Be
myself.
careful. What's the limit now as I come from the right-hand side? The limit as x approaches 1 from the positive side. What goes in for x? 1. What goes in for a? We don't know. That's what we're solving for. So it's just going to be 3 minus a. Now, go back to our definition of limits, our definition of continuity. In order for something to be continuous, the left-hand limit and the right-hand limit have to be what?
Connect, right?
To connect, they have to be equal, right? Make sense? So if the left-hand side equals the right-hand side, then it will be continuous. If it equals, in this case, the value at 1. That's kind of our lifesaver right there, okay? So in order to figure it out, take the limit from the left, the limit from the right, and just set them equal to each other. So A must be equal to a negative 4. So then A would be negative 4, and this would be a continuous function. Does that make sense?
Yeah.
Left hand equal the right hand, just set them equal to each other. I think I did that, didn't I? Fine, so it's a continuous, okay. So that's gonna be like, it's an example of this right here. Find a K that makes it continuous. It's just an application. Now, understand, I'm trying to teach you something here, because in every test, I'm not gonna tell you problems like that. I'm just gonna put it on the test. And you have to know to use a concept we've used in class. Oh, in order for it to be continuous, you have to go through all that thought process on your own. Okay? So as we get longer into the year, I am not gonna be giving you, oh, by the way, here's a tricky little question, but here's how you solve it. I'm not gonna do that. Okay? And on this test, there might be a surprise question. But I'm not gonna give you anything on a test that you haven't prepared for, that you don't know how to solve. It's just, you gotta figure out how to solve it. Make sense? Okay. All right, so there's an example. Here's another one. If you want to try it on your own, we can let you try it. On the video, I'll put the answer up here, or you can email me the answer or something. I have a bunch of practice problems on here. If you'd like to try any of them, I have the solutions for you. In fact, let's put those on video so you can see them all. So if you're watching the video and you want to freeze it, you can check the problem and the answer and see how you did. Okay? All right. And then here's some other practice examples we can do. Find the equation of the normal line. Piecewise is a continuous. This time there's 3 functions. Find the slope at a particular point. Describe behavior to the left if x equals 3. We can work on any of those that you want to work on. So I'll have those answers, but the video we're going to shut off. But you can try those problems you want to try. Oh my goodness. Could you not see that? Oh, good, you can see